Interior structure of the earth. Knowledge regarding the interior of the earth can be gained through the study of density, pressure, and temperature conditions as well as by studying the volcanic eruptions and seismology, that is, the science of earthquakes. Density, pressure, and temperatures are called artificial sources, whereas volcanic eruption and seismology are known to be the natural sources. The conditions of artificial sources, that is, density, pressure, and temperature, are shown. It is clear from this that all these three elements go on increasing as we go deep into the Earth's interior. First, we will talk about density. The outer crust of the earth is made up of continents. These continents are mainly composed of sedimentary rocks having a density of 2.7. Below these sedimentary rocks are the igneous rocks having a density of 3.5. Igneous rocks are also available at the surface at several places. Most of the old shields are made up of igneous rocks according to Newton's law of gravitation. The density of the earth as a whole is 5.5. This means that the density inside the earth should be very high. However, the density remains at low of 3.5 up to the depth of 400 kilometers and rises to nearly 5.6 at 2900 kilometers. After this, the density suddenly increases and rises up to 9.7. Beyond this depth, there is a ground increase in the density up to 5000 kilometers, where it again suddenly rises and reaches a high of 11 to 12 at the core. However, there are different views regarding the actual density at the core. For example, S.I. Sabaton is of the opinion that the density at the center must be as high as 17.9. Opinions differ regarding the exact cause of high density prevailing inside the earth. According to one school of thought, this is due to the pressure of overlying layers of material, while according to the other, the high density at the core is due to the pressure of heavy materials such as nickel and ferrous there. Second, we will talk about pressure. The pressure exerted on 1 square centimeter area of rocks inside the earth is known as pressure as prevailing in the interior of the earth. This pressure is caused by the weight of the overlying rocks. There is phenomenal increase in the pressure with depth. At the base of the crust, that is at the depth of 50 kilometers, the pressure is 1300 times the atmospheric pressure existing on the surface of the earth. In this way, each square centimeter of the rock area at this depth has to be bear a weight of 13 tons. At 2900 kilometer depth, the pressure is 13 lakh times the atmospheric pressure, and it reaches 35 lakh to 40 lakh times the atmospheric pressure at the core. Third, we will talk about temperature. The evidence of volcanic eruptions, arid hot springs indicates that high temperatures prevail in the interior of the earth. A progressive rise in the temperature with increasing depth is recorded in mines and deep wells all over the world. The average rate of increase being 1 degree Celsius for every 32 meters of descent. Normally, at this rate of increase in temperature, the rocks at great depths should be in a liquid state. At one time, on the basis of this view, it was accepted that the thin solid crust of the earth was perhaps resting on a molten core. The rate of increase in temperature is now considered to be variable, and there is no uniform increase from the surface to the center of the earth. The rate of increase in the overlying pressure makes the melting point higher, but only to a certain degree. In a per 100 kilometer, the increase is estimated at 12 degrees Celsius per kilometers. It is 2 degrees Celsius per kilometers in the next 300 kilometer and 1 degree centigrade per kilometer below it. By this calculation, the temperature is actually 2000 degrees Celsius at the core of the earth. The heat or rise in temperature is the result of internal forces automatic disintegration of radioactive substances, chemical reaction, and other sources keeping the interior hot. It indicates the liquid or perhaps gaseous conditions are prevailing at greater depths. But at the same time, there is a tremendous increase in the pressure of overlying layers on Earth's interior. Thus, even under extremely high temperature towards the central part of the Earth, the liquid nature of its core has acquired the property of a solid and is probably in a plastic state. The Earth is rigid and behaves mostly as a solid down to a depth of 2,900 kilometers because of such pressure conditions. Wherever even a slight release of pressure occurs, the underlying matter escapes to the surface and becomes molten because of high temperatures prevailing there. While solid materials melts inside the earth and the liquid also takes it to the properties of a solid, alluded above. Some scientists opine that the maximum temperature exists at the boundary of the outer crust, that is at a depth of 2,900 km. At this depth, the temperature is estimated to be the 4,000 degrees centigrade, whereas at the core it is only 2,600 degrees centigrade. Scientists are of the view that no rock can remain in solid state at such high temperature. Therefore, the Earth's interior should be in liquid or gaseous state. But high pressure inside the Earth raises the melting point and thus the interior should be in a solid state. But there is a limit to this process and no increase in pressure can raise the melting point indefinitely. It is clear from that melting point is higher than the actual temperature up to 1000 kilometers depth. Hence, the rocks should be in liquid state. The melting point from 1000 to 2900 kilometers is lower than the actual temperature, which means that this part of Earth's interior should be liquid. From 2900 to 4000 kilometers, the melting point is lower than the actual temperature, and this part should again be solid. Beyond 4000 kilometers up to the center of Earth, the melting point is lower than the actual temperature, which means that this part should be solid. Even if we accept the idea that rocks cannot remain solid at such high temperatures and they must be in liquid or gaseous state, the high pressure prevailing there must make them behave as rigid mass. Thank you. For more audiobooks, please subscribe to our channel and we will meet soon in the next audiobook. Thank you. Take care. We'll meet soon.